Some nights the light in a room seems to settle differently. The lamp in the corner, the soft glow from a window, the faint blue of a screen left dim in another room. They hold still in a way that feels almost deliberate, as if the light itself has decided to slow down with you. If this feels like a good place to rest tonight, you're welcome to stay. Now let's drift. There is a kind of light most people never think about. Not the light from a lamp or the sun outside a window, but the light that is already inside the eyes before a thought even forms. It arrives quietly without asking permission, and the mind simply receives it. Tonight this is where we begin, not with something loud or urgent, but with something so familiar that it almost disappears from notice: light. It seems that light has been travelling toward this exact moment for longer than most people imagine. Right now, in this room, in this quiet, the light touching the eyes did not begin here. Some of it left its source only a fraction of a second ago, like the glow from a lamp nearby. But some of it has been moving for much, much longer, crossing distances the mind can barely hold. Researchers have found that the light from the sun takes a little over 8 minutes to reach the Earth. That means the sunlight a person feels on their skin during the day already left the sun 8 minutes before it ever touched them. The sun a person sees is in a very real sense the sun as it was 8 minutes ago. It is a strange kind of memory, if it can even be called that. A memory carried not in thought but in light. The mind tends to treat the present moment as something solid, something happening exactly when it is felt. But scientists suggest that almost everything seen with the eyes is in some small way already in the past. Light does not move instantly. It moves quickly but not without time. So we're looking at a candle across a room. The light that just touched the eyes left the flame a tiny moment earlier. When looking at the moon, the light is over a second old. When looking at a star, the light may have left that star hundreds or thousands, or in some cases millions of years before it ever reached this night. There is something quietly comforting in that. The night sky then is less like a window and more like an old letter finally arriving. Some of those stars, scientists have noted, may not even exist anymore. Their light continues on its long journey, faithfully, long after the star itself has changed or faded or gone dark. So a person looking up at the sky is not only looking outward into space, they are also looking backward into time. Every point of light up there is a small fragment of something that already happened somewhere far away long ago. It may be that this is part of why looking at a night sky feels so calming to so many people. Not because of what is being seen, but because of what is being felt without quite knowing why. A sense of being touched by something old, something patient, something that has been travelling quietly, faithfully for longer than a single human life could hold. Light does not rush. Even though it moves faster than anything else known, it still takes its time getting here. It moves at its own pace, indifferent to clocks, indifferent to waiting. And somehow in that patience there is a kind of stillness. Psychologists often note that humans are deeply shaped by light even when they are not consciously aware of it. Long before clocks, long before calendars, the human body learned to read light as a kind of language. Brightness meant one thing, dimness meant another. The slow shift from day to evening was never just a visual change. It was a signal quietly understood by something deep inside the body long before the mind had words for it. This is worth sitting with for a moment, not because it needs to be understood completely tonight, but because it is the kind of thought that settles nicely into a quiet room. The eyes are not simply tools for seeing. They are in a sense instruments tuned to time itself. Every photon that reaches them carries a small piece of history, a small whisper of somewhere else, some other moment folded gently into now, and the body listens to this whisper more than people realize. There is a soft kind of irony in that. The light filling this room right now, however dim, however still, is doing the same thing the starlight does, just on a much smaller scale. It is carrying information from somewhere else to somewhere else, from a bulb to an eye, from a screen to a mind, from a distant star to a quiet bedroom, different distances, different speeds of arrival, but the same simple act again and again, light moving so something can be witnessed. It seems strange when thought about slowly enough that seeing anything at all means receiving something that has already happened. Nothing is seen as it is in the exact instant of seeing. Everything seen has already in some tiny or enormous way become the past by the time it reaches the eyes, and yet somehow this does not make the world feel distant. If anything, it can make it feel closer, as if everything seen everything, felt every quiet glow in a dark room is part of one long, soft, continuous arrival. Light travelling finely, landing gently on something that is ready to receive it. This is not something that needs to be solved tonight. It does not need an answer. It is simply something to notice the way one might notice rain on a window, without needing to understand the physics of it in that moment. Just a quiet awareness, a soft recognition that everything visible carries a small trace of somewhere else. The brain tends to interpret all of this so effortlessly, the strangeness of it rarely surfaces. Light enters the eye, and almost instantly, without any conscious effort, it becomes a room, a face, a window, a star. The mind builds the world this way, second by second, light by light, without ever pausing to consider how old that light might be by the time it arrives. But here now, in this slow and unhurried space, there is room to consider it. No need to reach a conclusion, no need to remember anything for later. Just a soft thought allowed to drift through the mind the way light drifts through the dark. Somewhere outside beyond this room, the night continues quietly. Streetlights hold their steady glow. Stars, if visible, sit fixed in their old patient positions, each one a small thread of light reaching the end of a very long journey. And here inside the light is gentler, dimmer, closer. But it follows the same rule. It always has. It moves, it arrives, it is received. There is something almost tender about that simplicity. Out of all the complicated things light can do, bending, scattering, reflecting, this is the part that matters most right now. It arrives. It always arrives. Quietly, faithfully, the way it has been arriving since long before there were eyes to notice it. And perhaps that is enough to hold on to for now, not the full picture. Not every detail, just this single soft idea that somewhere above this room ancient light is still falling gently through the dark on its way to somewhere the way it always has. And there is more to it than that. Long before scientists understood any of this, before telescopes, before equations, before anyone had measured the speed of anything, the body already seemed to know something about light, something quiet, something instinctive, as if understanding had been written into it long before language ever arrived to explain it. There is a particular kind of light that arrives only once a day and never quite the same way twice. The light just after sunrise, soft, low, slightly golden, settling over rooftops and fields and quiet kitchen windows. Most people have felt it without ever really looking at it. It comes, it warms the air for a while, and then it moves on, changing shape as the hours pass. It may be that this is one of the most familiar kinds of light in a person's life, and also one of the least examined. Light changes colour throughout the day, not because the sun itself is changing, but because of the angle at which its light reaches the earth. In the early morning and again in the evening, sunlight travels through more of the atmosphere to reach the eyes, and that longer path gently shifts its colour toward warmer tones. Soft oranges, gentle pinks, quiet golds. By midday, when the sun sits higher, its light has a shorter path to travel, and it appears cooler, whiter, more direct. Scientists describe this in terms of something called colour temperature, measured in a unit called Kelvin. It is a strange kind of measurement because warmer-looking light, the soft orange of a sunset, actually has a lower number, while cooler-looking light, the crisp blue-white of midday, has a higher one. The names feel almost backwards, warm light measuring low, cool light measuring high. But perhaps that mismatch says something gentle about how differently the eye and the instrument see the same thing. The body, long before anyone had measured Kelvin or built an instrument to study it, already seemed to respond to these shifts. Researchers have found that warmer, lower light tends to feel more relaxing, more intimate, easier to rest within. Cooler, brighter light tends to feel more alert, more active, more suited to movement and focus. This is part of why a candle feels different from an office light, why a fireplace feels different from a fluorescent bulb. Even if a person could not explain the difference in words, there is something quietly moving in that. The human body, without ever studying physics, somehow learned to read the temperature of light and to feel safe or alert because of it. For most of human history, the only light available after sunset came from fire. A flame, a lantern, a candle, and fire almost without exception produces warm light, gentle oranges, and ambers, rarely anything close to the blue-white of daylight. For thousands and thousands of years, nighttime light meant warm light. The two were almost inseparable. It seems that this long relationship may still echo somewhere inside the body today. Even now, in homes filled with electric light, warm bulbs are often chosen for bedrooms, for living rooms, for the hours just before sleep, while cooler, brighter light is more often reserved for kitchens, for offices, for daytime tasks. Whether this is something taught, something cultural, or something quietly inherited from a much older relationship with firelight is not entirely settled. But the pattern itself is gentle to notice. Warm light evening, cool light day. Psychologists often note that colour is rarely just colour to the human mind. It carries meaning, mood, memory, association, often without conscious awareness. Warm light may feel comforting, partly because it has always been there in firelight, in lanterns, in the early light of dawn, present at the safest, calmest parts of human history. Cool light, by comparison, has only existed in everyday life for a relatively short span of time, arriving alongside electricity, fluorescent lighting, and eventually screens. There is something almost touching in imagining a small flame somewhere in the deep past, flickering inside a cave or a hut, its warm and unsteady light becoming slowly over countless generations, and something the body learned to trust. And light, of course, does not only shift in colour throughout the day, it shifts in intensity as well, in brightness, in how directly it falls. Morning light tends to be softer, less concentrated, easier to look at. Midday light is sharper, more direct, harder on the eyes. By evening, the light softens again, lower, gentler, slanting differently through windows and across rooms. This rhythm repeating every single day is something the body has learned without ever being taught in words. Researchers studying human behavior have found that exposure to brighter, cooler light earlier in the day tends to support alertness and a feeling of being awake, while exposure to dimmer, warmer light in the evening tends to support a feeling of slowing down, of preparing to rest. The light itself seems to carry a quiet instruction even when no one is consciously listening for it. It may be that this is part of why staying in a dim, warmly lit room in the evening can feel so naturally calming, almost like settling into something familiar, something old. Not because of anything dramatic, simply because warm, low light has always meant evening has come, the day is closing. It is safe to slow down now. There is a kind of trust built into that pattern, a trust formed slowly across an enormous stretch of time long before anyone called it science. The mind quietly registers all of this mostly without notice. A person walking outside on a quiet morning might feel simply this is nice without ever thinking about Kelvin or wavelengths or the angle of the sun through the atmosphere. The feeling arrives first. The explanation, if it ever arrives at all, comes much later, if it comes at all. Perhaps that is one of the gentler truths about light. It does not need to be understood to be felt. A warm lamp in a dim room creates a certain kind of comfort whether or not anyone in that room could explain why. A cool, bright morning creates a certain kind of clarity whether or not anyone stops to consider the physics behind it. The body simply knows in its own quiet way long before the mind catches up. There is also something gentle in the way light moves through ordinary days without ever repeating itself exactly. No two sunrises are identical, not really. The angle might be nearly the same, the timing close, but the particular clouds, the particular moisture in the air, the particular dust and haze drifting overhead, all of it shifts the colour, even if only slightly. Evidence suggests that the exact colour of a sunset depends on countless tiny variables, the composition of the atmosphere, that day, recent weather, even distant events like volcanic activity, all able to shift the hue of an evening sky in ways too subtle for most people to notice, yet present all the same. So in a quiet sense, every sunset is something that has never happened before in quite that way, and will never happen again in quite that way either. Small ordinary kind of uniqueness repeating itself daily, mostly unnoticed. It is worth letting that settle for a moment. Not to remember it, just to feel it the way one might feel the last bit of warmth leaving a room as evening arrives. Light in this way becomes something like a quiet companion to time itself. It does not announce the hour. It simply changes gradually, gently, and the body in its own old and instinctive way changes little too. Brighter light asks for alertness. Warmer, dimmer light invites a slower pace. Neither needs to be understood to be followed. The body has been following this rhythm for longer than memory can reach. And somewhere beneath all of this, beneath the colours, the temperatures, the shifting angles of sunlight through a day, there is something even quieter still happening. Something not in the world outside, but inside the body itself. A kind of light the eyes do not exactly see yet somehow still respond to. Something that has been quietly shaping rest and wakefulness long before anyone thought to study it closely. That part of the story is still ahead, waiting patiently the way light always seems to wait until the moment is ready to receive it. There is a part of the eye that does not exist to help anyone see. It sits quietly within the retina doing its work in the background, never forming a single image, never contributing to a single memory of a face or a room or a sky. And yet it has been there the whole time, watching light in its own private way. It may be that this is one of the more surprising things about human eyes. Not everything inside them is meant for vision. For a long time, scientists believed the retina existed for one purpose only: to gather light and turn it into images the brain could interpret. Rods for dim light, cones for colour, and detail, a finely tuned system built entirely around seeing. But researchers have found something else living. Among those cells, a small population of neurons that do not seem interested in shapes or colours or faces at all. They are called intrinsically photosensitive retinal ganglion cells, and their only real concern is brightness itself, how much light is present, and how that amount is changing. These cells do not care what the light reveals. They do not notice a window or a lamp or a face nearby. They simply register light gently, continuously, the way a hand might rest near a fire, without needing to know its shape, only its warmth. It seems that this quiet sensitivity to brightness plays a far larger role in daily life than most people ever realize. These light-sensing cells send their signal not to the part of the brain responsible for vision, but to a small ancient structure deep within it, often described as the body's internal clock. There, the information is used for something almost nothing to do with seeing and almost everything to do with timing. There is something tender in imagining that. A part of the eye working in near total silence, never showing anyone what it sees, simply whispering to a much older part of the brain, it is bright now, or it is growing dark. This internal clock tucked deep within the brain helps regulate something researchers call the circadian rhythm, a roughly daily cycle that influences body temperature, hormone release, hunger, and the rise and fall of alertness throughout a day. Light is its primary cue, not food, not temperature, not sound light. Brightness in the morning helps anchor the rhythm to wakefulness. Dimness in the evening helps gently release the body toward rest. What we understand so far suggests this rhythm runs even without external light at all. In carefully controlled studies where participants lived for extended periods without windows clocks or any indication of time, their bodies still settled into a cycle close to 24 hours, drifting only slightly without daily light to correct it. As if something inside already knew roughly how long a day should be, and simply needed light to keep that knowledge gently in tune. There is something quietly remarkable in that. A rhythm written somewhere inside the body long before clocks were ever invented, patiently waiting for light to help it stay aligned. One detail researchers have paid particular attention to involves the color of light, not just its brightness. The cells responsible for circadian timing appear especially sensitive to a narrow band of blue light, the kind naturally abundant during daylight hours, particularly around midday. Evidence suggests this is part of why screens, lamps, and devices that emit blue-toned light in the evening can quietly interfere with the body's sense of approaching night. Not because the light is harmful in any dramatic sense, but because it resembles daylight closely enough to gently confuse an ancient light-sensitive system that has relied on consistent cues for a very long time. It's not a flaw in the body, it is simply an old system encountering a new kind of light it never had to interpret before. Neuroscientists have observed that this circadian influence reaches far beyond simply feeling sleepy or awake. It touches body's temperature, which tends to drop gently in the hours before natural sleep. It touches the release of certain hormones, including one called melatonin, which rises as darkness falls and quietly recedes again with daylight. None of this requires conscious thought or effort. It happens in the background the way breathing continues without being asked to. There is a kind of devotion in that, if such a word can be used for biology. A system working continuously day after day, asking for nothing in return except a little consistency, a little rhythm, a gentle alternation between light and dark. Psychologists often note that disruption to this rhythm through irregular light exposure, shift work, or long periods spent indoors away from natural daylight can leave people feeling foggy, unsettled, or quietly out of step with themselves, even when nothing else in life has changed. As though some small steady thread inside has come slightly loose, not broken, just loosened, waiting patiently to be gently retightened by something as simple as morning light. It may be that this is one of the more overlooked truths about light. It is not only something seen, it is something felt by parts of the body that have nothing to do with seeing at all. A presence registered quietly, continuously beneath conscious awareness, shaping rest, shaping energy, shaping the soft architecture of an ordinary day. The mind quietly registers brightness long before it consciously notices a room growing dim. By the time someone thinks it's getting dark in here, the light-sensitive cells deep within the eye have already been reporting that change for some time, already nudging the internal clock a little closer toward the evening, already in some small way preparing the body to slow down. There is something comforting in imagining this unseen conversation, light and eye, and an ancient inner clock speaking to each other constantly, gently, without needing language, without needing attention, simply continuing the way it has for longer than written history can account for. And what is quietly fascinating is that this same rhythm appears not only in humans but across an enormous range of living things, plants that open and close with the sun, animals that wake and rest according to light, even some of the simplest organisms on Earth. Cells with no brain at all still seeming to keep some rough sense of day and night, as if this rhythm is not something invented by complexity, but something woven into life itself, present long before eyes, long before brains, long before anything resembling thought. It seems that light in this sense is not only something the world offers, it is something life has always been listening for. There is a quieter layer to this one that most people never consider, something that happens not when light arrives, but in the particular way the body responds when it begins to fade. There is a question that almost never gets asked out loud because the answer seems so obvious. What colour is an apple? Red, most people would say without pausing, and yet in a way that is gentle to sit with that answer is not quite true. It seems that colour as it is experienced does not exist out in the world the way most people imagine. Researchers have found that objects themselves have no colour at all. What they have is a surface that absorbs some wavelengths of light and reflects others. An apple looks red because its surface reflects light from the longer end of the visible spectrum back toward the eyes while absorbing most of the rest. The apple is not red. The apple is simply doing something to light, and the eyes and then the brain are doing the rest. There is something quietly disorienting in that, in a soft way, not an alarming one. Colour, it turns out, is less something found in the world and more something made somewhere inside in response to it. Light itself, as it travels, carries no colour either. What is often called white light, ordinary daylight, is in fact a mixture of many wavelengths together. A whole spectrum travelling as one. It is only when that light interacts with something, a prism, a raindrop, the surface of a leaf, that it begins to separate or to be selectively absorbed and reflected, and only then does anything resembling colour begin to take shape. Studies indicate that the wavelengths themselves remain in a strict sense colourless. Colour is something that happens afterward quietly, privately, inside a nervous system capable of interpreting them. It may be that this is one of the more tender truths about the world. So much of what feels vivid and certain, the deep green of a forest, the gold of late afternoon light, is not something simply received. It is something gently constructed, moment by moment, somewhere behind the eyes. The human eye contains 3 types of light-sensitive cells called cones, each tuned to respond most strongly to a different range of wavelengths roughly corresponding to red, green and blue light. Nearly every colour seen by human eyes is created through some combination of these 3 signals blended together by the brain into the vast and seemingly endless range of colours a person can recognise. Neuroscientists have observed that the brain does this blending so seamlessly, so instantly, that the underlying process remains entirely invisible. No one experiences 3 separate signals being combined. They simply experience the colour blue or violet or the soft in-between shade of a twilight sky. There is something almost musical in that idea. 3 simple notes layered together in countless combinations, quietly composing the entire visible world. What makes this even gentler to consider is that not everyone hears this particular music in quite the same way. Evidence suggests that the experience of colour can vary subtly from person to person, shaped by small differences in the eyes, the brain, even mood and context. Some people see colours slightly more vividly than others. Some perceive subtle shifts in hue that others do not notice at all, and in cases where one or more types of cone cells function differently, colour blindness. The entire experience of colour can shift in ways difficult for others to fully imagine. It seems that no 2 people are ever entirely certain they are seeing quite the same red, the same blue, the same gentle grey of an overcast morning. The word may be shared. The experience underneath it may be quietly, privately different. There is no need to resolve that thought. It can simply rest there unanswered, the way many gentle uncertainties are allowed to. This quiet construction of colour becomes even more noticeable in low light. As evening deepens and brightness fades, The cone cells responsible for color vision become less effective, while the more light-sensitive rod cells, which detect brightness but not color, become primarily responsible for vision. This is part of why in very dim light the world can seem to lose its color, almost entirely shifting into soft grays and muted blues, even though the actual light reflecting off objects has not changed at all. What we understand so far suggests this shift, sometimes called night vision or scotopic vision, is one of the more elegant compromises the eye makes. In exchange for the ability to see at all in near darkness, the richness of colour is quietly set aside, almost like the eye is deciding gently that detail matters less right now than simply being able to see shapes and movement in the dark. There is something tender in imagining that exchange, as if the eyes faced with diminishing light choose calm over clarity, choose enough over everything. The sky itself offers one of the more familiar examples of colour being made rather than simply existing. Daytime sky appears blue, not because the sky is blue in any solid sense, but because shorter wavelengths of light, the blues scatter more easily through the gases of the atmosphere than longer wavelengths like red or orange. This is sometimes called Rayleigh scattering, named after the physicist who studied it. Blue light bounces around the atmosphere in every direction, filling the sky with its scattered presence, while longer wavelengths largely continue on their original path. At sunset, when sunlight travels through far more atmosphere to reach the eyes, most of that blue light scatters away long before it arrives, leaving the warmer reds and oranges to dominate what is finally seen. The sky does not change. The path light takes through, it does. Psychologists often note that people frequently describe sunsets as feeling emotional, almost meaningful in a way that midday skies rarely do. Perhaps part of that feeling comes from this very fact that a sunset is not simply beautiful, it is the visible record of light, travelling the longest, most difficult path it will take all day, arriving finally warmly after the greatest struggles. There is no need to overstate that. It is simply a small, quiet thought, the kind that fits comfortably into a dim room at night. The brain tends to do something else remarkable with colour as well, something called colour constancy. A white object will continue to appear white roughly whether viewed under the cool blue light of midday or the warm orange light of a lamp at night, even though the actual wavelengths of light reflecting off it have shifted considerably. The brain quietly adjusts, compensating for the surrounding light, working to preserve a stable sense of what an object's true colour is, even as the literal light reaching the eyes changes from moment to moment. It is in its own quiet way an act of trust, the brain choosing consistency over literal accuracy, deciding that a familiar white shirt should still look white, rather than presenting every small shift in lighting as a dramatic change in the world. There is something gentle in that kind of loyalty, the mind quietly protecting a sense of stability even as the world around it continues quietly to shift. Some of the most vivid colours in nature are not created by pigment at all, but by structure. The deep blue of certain butterfly wings, the shifting green and violet of a peacock's feathers. These colours often come not from any blue or green substance within the wing or feather itself, but from microscopic structures that bend and reflect light in particular ways, creating colour through geometry rather than chemistry. Researchers studying these structural colours have found that they can shift slightly, depending on the angle from which they are viewed, the same feather appearing blue from one direction and faintly green from another. It may be that this too says something soft about colour in general, that it is never quite as fixed as it feels. It bends with light, with angle, with the quiet architecture of whatever it touches. There is a stillness in thinking about all of this slowly rather than quickly. Colour does not arrive in the world the way sound arrives or the way warmth arrives. It is gathered fragment by fragment, wavelength by wavelength, and assembled somewhere private, somewhere internal into something that feels to each person simply real. Tonight, in whatever dim light remains in this room, the colours present are not quite fixed things either. They are quiet collaborations between light and surface and an aging, ever-adjusting set of cells doing their slow work without ever announcing it. And just beneath this question of how colour is made, there is something even softer waiting, something to do with the way the eyes themselves change shape in darkness, quietly preparing long before sleep ever arrives for the absence of light altogether. There is a particular stillness that follows rain, just after the clouds begin to thin, and the sun finds its way back through the grey. Many people have stood in that exact moment without realising it, the air still damp, the light suddenly soft and golden again. And sometimes in that quiet window something appears in the sky that has captured human attention for longer than written history can fully account for. It seems that a rainbow, for all its familiarity, still holds a surprising amount of quiet complexity inside it. A rainbow forms when sunlight enters a raindrop and bends. Light travelling through air moves at one speed, but as it enters water, a denser medium, it slows down slightly, and that change in speed causes it to bend, a process scientists call refraction. Once inside the raindrop, the light reflects off the inner surface, bounces backward, and as it exits, the drop it bends once more, because different wavelengths of light bend by very slightly different amounts. Red bending the least, violet bending the most. The light separates as it leaves the drop, spreading gently into the full range of colour most people recognise instantly, even as children, long before anyone explains what is actually happening. There is something tender in that. A child pointing at a rainbow has, without knowing, it just witnessed a small, ordinary miracle of physics, water, and light working together, briefly, gently, to reveal something usually hidden inside ordinary daylight. Researchers have found that no single raindrop produces the rainbow that any one person sees. Each drop bends and separates light into its own narrow band of colour sent off at a particular angle. The red a person sees comes from one set of distant raindrops. The violet comes from an entirely different set. What appears to be one continuous, gentle arc is actually the combined effort of countless individual drops, each one contributing only a sliver of colour, only a small piece of the full picture. It may be that this is part of why no two people standing even a short distance apart ever see exactly the same rainbow. Each person's eyes receive light from a slightly different set of raindrops bent at slightly different angles, depending on their own particular position relative to the sun and the rain. A rainbow in this sense is less like an object in the sky and more like a private arrangement, a kind of light unique to wherever a person happens to be standing in that exact moment. There is something quietly moving in that thought, a shared experience that is underneath it, deeply individual. Millions of people may look toward the same patch of sky and use the same word rainbow, while each of them is in the gentlest sense looking at something slightly different, something made just for the place where they happen to stand. The shape of a rainbow is also rarely fully seen. What most people witness is an arc, but studies indicate that a rainbow is in its complete form a full circle. From the ground, the horizon interrupts the lower half, hiding it from view. From an airplane on rare occasions, or from a high vantage point with rain falling, below it becomes possible to see the entire circle complete and unbroken. A detail most people go their whole lives without ever encountering. It seems fitting somehow that something so often associated with wholeness, hope, completeness exists in its truest form as a perfect circle, even though most of it stays quietly hidden beneath the horizon, unseen by almost everyone who ever looks up at it. Sometimes faint and pale, a second rainbow appears above the first, its colours reversed red on the inside instead of the outside. This happens when light reflects twice inside a raindrop instead of once, losing some intensity with each additional bounce, which is part of why this second arc always appears softer, dimmer, easier to miss entirely if attention is not paid. Neuroscientists studying visual attention have observed that the brain tends to notice the brighter, more saturated rainbow, first often overlooking the fainter one entirely, unless someone specifically directs their gaze toward it. There is something gentle in that small detail, a second, quieter version of the same phenomenon existing right alongside the first, simply waiting patiently to be noticed. Between the two rainbows, when both are visible, the sky often appears slightly darker, a band of deeper grey nestled between the brighter colours above and below. This is sometimes called Alexander's dark band, named after the ancient scholar who first described it many centuries ago. It occurs because very little light reaches the eyes from that particular region of sky, most of it having already bent away in other directions. It is in its own quiet way a kind of negative space defined not by what is there, but by what has been gently redirected elsewhere. It may be that even darkness in this small instance has its own logic, its own quiet explanation, rather than simply being an absence with nothing behind it. What we understand so far suggests that rainbows have appeared in human storytelling and folklore across nearly every culture throughout history long before anyone understood the physics of refraction and reflection. Bridges between worlds, signs of peace, paths walked by gods or spirits, promises remembered after a storm. Psychologists often note that humans have a deep tendency to find meaning in things that are beautiful, temporary, and slightly mysterious, and a rainbow holds all three qualities at once. Vivid, fleeting, never quite explainable just by looking at it. There is no need to choose between the science and the wonder. They can rest together quite comfortably, the careful explanation of bending light existing alongside the simple old feeling of looking up and feeling somehow a little more at ease. Rainbows are not the only place where light reveals itself this way. A thin film of oil on a wet road or the inside of a soap bubble can produce similar shifting bands of colour caused not by raindrops but by extremely thin layers reflecting and interfering with light in delicate, precise ways. Evidence suggests that wherever light is asked to pass through or bounce between very fine layers of different materials, it tends to reveal a hidden rainbow of its own. Smaller, quieter, easy to walk past without ever noticing. It seems that colour hidden within ordinary light is far more present in daily life than most people ever pause to consider waiting quietly in raindrops, oil films, bubbles, glass, needing only the right angle, the right light to gently reveal itself. There is a soft kind of comfort in imagining how much of this happens constantly all around, completely unnoticed. Light bending, separating, recombining, quietly performing the same elegant process it has performed for as long as there has been light and water and air to meet it. Most of it asks nothing of anyone. It simply happens patiently whether or not there is someone present to look up and see it. There is a quieter layer to this one that most people never consider something to do with all the colour sitting just outside what a rainbow shows, light existing at the very edges of what human eyes were ever built to notice. There is a kind of light that has been touching skin for as long as there has been skin to touch, and yet it has never once been seen by a single human eye. It seems strange to say that something can be felt constantly and never once witnessed, but this is exactly the situation with much of the light that surrounds everyday life. Human eyes, for all their sensitivity, only detect a narrow band of what light actually is, a small window. Scientists call the visible spectrum sitting quietly between two much larger ranges that stretch on invisibly in either direction. Just beyond red on one edge of that window lies infrared light waves slightly too long for human eyes to register. Just beyond violet on the other edge lies ultraviolet light waves slightly too short. Both are light in every technical sense, the same fundamental kind of energy as the colours that can be seen, simply existing just outside the narrow range human biology happens to be built to notice. There is something quietly humbling in that. The world is not only what is seen, it is also in some considerable part everything that light is doing just beyond the edges of sight. Infrared light is something most people have already felt without realizing what it was. Researchers have found that a significant portion of the warmth felt from sunlight or from a fire or from a heated surface comes not from visible light at all, but from infrared radiation, invisible waves that carry heat directly into the skin. This is part of why a sunny day can feel warm even when the sky looks no different in colour than a cooler one, and part of why standing near a fire creates a gentle, immediate warmth on the skin, long before any visible flicker reaches the eyes from across a room. It may be that warmth itself in this sense is a kind of light, not seen but felt, arriving quietly on the skin the way visible light arrives in the eyes. Some animals, unlike humans, can actually see portions of this infrared range. Certain snakes, for example, have specialized organs near their face capable of detecting infrared radiation, directly allowing them to sense the body heat of nearby animals as a kind of image even in complete darkness. Scientists are still exploring the full details of how this infrared sense is processed in the snake's brain, but what is understood so far suggests it functions almost like a second heat-based vision layered quietly alongside ordinary sight. There is something gently humbling in imagining that. A world of warmth glowing faintly around every living creature visible to some eyes and completely invisible to others simply because of how each creature happened to evolve. On the opposite edge of the visible spectrum lies ultraviolet light waves, slightly shorter and more energetic than violet. Human eyes cannot see it directly, though it plays a quiet ongoing role in everyday life regardless. Ultraviolet light is responsible for the way skin gradually darkens after time spent in the sun, and for the way certain materials seem to glow faintly under particular kinds of light, an effect caused by those materials absorbing ultraviolet energy and re-releasing it as visible light, a process called fluorescence. Many flowers invisible to the unaided human eye reveal intricate ultraviolet patterns when viewed through instruments capable of detecting that range, patterns that appear to function almost like landing markers gently guiding bees and other pollinators toward the center of the flower. What looks to a person like a simple uniform petal may to a bee appear as something closer to a glowing path, an invitation rendered entirely in light no human eye was ever designed to perceive. There is something quietly moving in that, a flower speaking a language of light that has nothing to do with human eyes at all, a private conversation between bloom and bee, continuing in every garden completely unseen by the very people walking past it. Bees, it turns out, see a meaningfully different slice of the light spectrum than humans do. Studies indicate that bee vision extends into the ultraviolet range, while lacking sensitivity to red light almost entirely, meaning a red flower, vivid and bold to human eyes, may appear comparatively dull or even invisible to a bee, while a flower that looks plain or pale to a person might appear vivid and richly patterned to a bee's eyes, alive with ultraviolet detail, completely hidden from human perception. It seems gentle to consider that no single creature sees the full truth of light. Each eye evolved under its own particular pressures, opens onto its own particular window, narrower in some places, wider in others, but never complete. The world is in this sense larger than any single perspective could ever fully hold. Some insects and birds can also detect polarized light, a quality of light related to the direction in which its waves vibrate, something entirely undetectable to human eyes without specialized equipment. Evidence suggests that certain birds use this ability to help navigate during long migrations, sensing subtle patterns in polarized sunlight scattered across the sky, even on overcast days when the sun itself is not directly visible. The mind quietly registers in a person only the brightness or dimness of an overcast sky. A migrating bird flying somewhere above may be reading an entirely different layer of information from that very same sky, an invisible map folded gently into ordinary daylight. There is a tenderness in imagining that the same sky offering such different information to such different kinds of attention. Beyond infrared and ultraviolet, the full electromagnetic spectrum continues even further in both directions through microwaves and radio waves on one end, through X-rays and gamma rays on the other, all of it the same essential phenomenon, waves of energy, travelling at the same fundamental speed, simply differing in how long or short those waves happen to be. What is called visible light is in the broadest sense only the tiniest sliver of this entire range, a narrow band that happens to align with the kind of energy most useful for life on a planet lit primarily by one particular star. Psychologists often note that there is something quietly reassuring for many people in learning that the visible world is not the whole world, that vast amounts of activity, communication and structure exist constantly just beyond what any human eye could ever directly witness. Not hidden in any secretive sense, simply existing outside a narrow biological window, the way a radio carries music through air that remains to unaided ears completely silent. There is no need to feel that this makes the visible world smaller or less significant. If anything, it can feel like the opposite. A quiet reminder that even the most familiar ordinary light, the lamp in this room, the last soft trace of evening through a window, is only one visible note in a far larger, mostly silent composition, most of which continues quietly endlessly whether anyone is paying attention to it or not. And further inward past these outer edges of light, something else has been waiting all along. Not outside the eye this time, but within it, in the particular way the eye itself quietly reshapes its world the moment true darkness finally begins to settle in. There is a particular kind of patience the eyes practice every single night, one that almost no one ever notices happening, because it happens slowly, gradually, far beneath conscious awareness. It seems that stepping from a bright room into darkness is rarely as simple as it feels. For the first few moments, very little can be seen at all, only vague shapes, faint outlines, a kind of soft, grey uncertainty. And then slowly the room begins to reveal itself again, not all at once, but gradually, as though the darkness itself were being gently dissolved from the inside. Researchers have found that this process, often called dark adaptation, is one of the more remarkable adjustments the human body performs without ever being asked to. The eye is not simply waiting for darkness to lift. It is actively changing cell by cell to become more sensitive to whatever small amount of light remains. Within the retina sit two main types of light-sensitive cells, cones and rods, each suited to a very different kind of seeing. Cones concentrated near the centre of the retina are responsible for colour and fine detail, but they require a relatively significant amount of light to function well. Rods spread more widely across the retina cannot detect colour at all, but they are remarkably sensitive to even tiny amounts of light, and it is largely through these cells that anything can be seen at all, once true darkness sets in. There is something quietly moving in that division of labour. One set of cells devoted to colour and clarity, another devoted simply to making sure the world does not disappear completely once the light fades. What we understand so far suggests that rods become fully sensitive only gradually, sometimes taking 20 minutes or more to reach their full capability in darkness. This happens because of a light-sensitive molecule within the rods called rhodopsin, sometimes referred to as visual purple, which is broken down by exposure to bright light and must be slowly regenerated once that light is removed. In bright daylight, rhodopsin remains mostly depleted, almost unnecessary, since cones are doing most of the work. But the moment darkness begins, the eyes quietly begin rebuilding it, patiently, steadily preparing for a kind of vision that requires far greater sensitivity. It may be that this is part of why stumbling occurs in the first moments after a light is turned off, the world briefly unreadable, not because the eyes have failed, but because they are still quite literally rebuilding their own readiness in the dark. This rebuilding follows a fairly predictable curve. Cones adjust relatively quickly, reaching much of their dark sensitivity within 5 to 10 minutes, while rods continue adjusting far more slowly, gradually taking over as the dominant source of vision the longer darkness continues. Scientists studying this process have noted that sensitivity can increase by a factor of many thousands once full. Dark adaptation is reached, meaning the eyes after enough time in darkness become capable of detecting light so faint it would have been completely invisible only minutes earlier. There is something tender in imagining that. The eyes do not give up in darkness. They simply slow down, recalibrate, and quietly become something else entirely, an instrument built not for colour or sharpness, but for noticing the smallest, faintest trace of light remaining. This is also part of why in very dim conditions, looking slightly to the side of a faint object rather than directly at it can sometimes make that object easier to see. Cones cluster most densely at the very centre of the retina, the area used for direct detailed focus. Rods are more abundant toward the edges, so in deep darkness the periphery of vision can quite literally see more than the very centre can. Astronomers have long used this technique when observing extremely faint stars, glancing slightly away from a star rather than directly at it, allowing the more light-sensitive edges of vision to catch what the centre alone would miss. It seems gentle to consider that in darkness, looking slightly away from something can sometimes be the better way to truly see it. The opposite process, adjusting from darkness back into bright light, happens far more quickly, usually within a matter of seconds or a couple of minutes. This is part of why stepping outside into daylight after time spent in a dark room can feel briefly overwhelming, even painful, the eyes needing only a short adjustment before settling comfortably again. Neuroscientists have observed that this asymmetry, slow adaptation into darkness, fast adaptation into light likely reflects an old evolutionary balance, the ability to quickly regain sharp vision in sudden brightness, being just as important across a long evolutionary history as the ability to gradually adjust to fading light at dusk. There is something quietly wise in that imbalance, the body treating brightness as something requiring quick response and darkness as something that can be allowed to settle in slowly, gently, without urgency. Some animals carry an additional advantage in low light that humans do not. Many nocturnal creatures, cats among the most familiar examples, possess a structure behind the retina called the tapetum lucidum, a reflective layer that bounces light back through the retina, a second time giving the light-sensitive cells an additional opportunity to detect it. This is part of why a cat's eyes seem to glow faintly when caught in headlights or lamplight. At night, the visible result of light being reflected back outward after its second pass through the retina. Humans do not have this layer, and so the human eye, even after full dark adaptation, remains considerably less capable in true darkness than the eyes of many nocturnal animals. It may be that this is simply a quiet reminder that human eyes were never built primarily for night. They were built across a long evolutionary history mostly for daylight, adapted only gradually, only partially to the dark. Psychologists often note that this gradual transition into night vision may be part of why darkness itself can feel different, depending on how long someone has been sitting within it. The first few minutes in a dark room often feel the most uncertain, the most unfamiliar. But as the rods slowly awaken, as the eyes adjust, that same darkness frequently begins to feel softer, more navigable, somehow less complete than it first seemed. There is something almost reassuring in the realization that darkness, given enough quiet time, is rarely as absolute as it first appears. The mind quietly registers all of this without needing to understand the underlying biology. A person sitting in a dim, quiet room simply notices after a while that they can see a little more than they could when they first sat down, the outline of a chair, the edge of a window, details that were entirely invisible only minutes before. The explanation, rhodopsin regenerating rods slowly awakening, sits quietly underneath, present but unnecessary for the experience itself to feel calm, gradual and complete. There is something pixel in imagining the eyes this way, not as static instruments fixed and unchanging, but as something closer to living, responsive things, constantly adjusting, constantly recalibrating, quietly devoted to making sense of whatever light happens to be available, however little that may be. And somewhere just beyond this slow, patient adjustment of the eyes themselves, there is something else, something far larger, where light bends not because of biology at all, but because of gravity, vast and invisible, reshaping the very path light is allowed to travel through the universe. Most people looking up at a clear night sky assume they are seeing stars exactly where they appear to be. It is a reasonable assumption. It is also in a great many cases quietly untrue. It seems that light, for all its steadiness, does not always travel in a perfectly straight line. Scientists suggest that one of the more elegant discoveries of the past century is the realization that gravity itself can bend the path. Light takes not because light has any mass to be pulled by gravity in the traditional sense, but because gravity bends the very fabric of space that light is traveling through. Light continues moving in what feels to it like a straight line. It is space itself that has quietly curved beneath it. There is something gently disorienting in that idea, and also something strangely calming. The universe is not entirely rigid. It bends. This bending of light by gravity is called gravitational lensing, and researchers have found that it occurs wherever an enormous mass, a star, a galaxy, an entire cluster of galaxies sits along the path, light travels on its way toward an observer. The light passing near that mass curves slightly around it, the same way water gently curves around a stone resting in a stream. From a great distance, this curving can make objects appear shifted from their true position, stretched into strange arcs, or in some rare and striking cases duplicated the same distant galaxy, appearing more than once in the same patch of sky, its light having travelled multiple slightly different paths around the same massive object before finally reaching an observer. It may be that this is one of the more quietly astonishing truths the universe offers. A single galaxy captured several times over in the same photograph, not because it exists more than once, but because its light took more than one road to get here. The very first confirmation of this bending came not from a laboratory, but from the sky itself during a total solar eclipse. In the year 1919, astronomers measured the apparent position of stars near the Sun during the brief darkness of an eclipse, comparing it to where those same stars appeared months earlier, when the Sun was nowhere near them in the sky. The stars seem to have shifted slightly, exactly as predicted by a new theory of gravity proposed only a few years before. Studies indicate that this single observation helped confirm one of the most significant ideas in the history of physics: the understanding that massive objects do not simply pull on light, they reshape the space light travels through. There is something quietly moving in imagining that moment, scientists standing beneath a darkened sky, watching starlight bend gently around the Sun, confirming almost gently that the universe behaves in ways far stranger and more graceful than anyone had previously imagined. In the decades since gravitational lensing has become something astronomers rely on, almost like a borrowed tool, a natural magnifying glass built not of glass at all but of mass and curved space. When a massive galaxy cluster sits between Earth and a much more distant object, its gravity can bend and focus the light from that distant object, sometimes magnifying it enough to be seen clearly, even though it would otherwise be far too faint or far too distant to observe directly. Researchers have found galaxies through this method that existed when the universe was only a small fraction of its current age, their faint light gathered and gently amplified by the gravity of something enormous standing quietly in between. It seems fitting somehow that some of the oldest light astronomers have ever observed only became visible because something else equally vast gently helped carry it the rest of the way. In particularly precise alignments, when a massive object sits almost perfectly between an observer and a distant source of light, the bending becomes symmetrical in every direction, producing what is called an Einstein ring, a thin glowing circle of light surrounding the massive object at its center, formed entirely from the light of something far behind it, bent equally on all sides. What we understand so far suggests this effect requires an extraordinarily precise alignment to occur clearly, which is part of why when one is observed, astronomers often pause a little longer than usual over the image, aware of just how rare that particular alignment is. There is something tender in imagining that a perfect ring of borrowed light formed only because three things, an observer, a massive object and a distant galaxy, happen to fall into an almost impossibly precise line with one another, across distances too vast for ordinary numbers to feel meaningful. Gravitational lensing is not limited to the enormous scale of galaxies and clusters either. Even individual stars, scientists have noted, can produce a much smaller, much more fleeting version of this same effect, briefly bending and magnifying the light of a more distant star that happens to pass closely behind them as seen from Earth. This subtle temporary brightening, called microlensing, has helped astronomers detect distant planets that would otherwise be completely invisible planets, revealed not by being seen directly, but by the small gentle way their presence and their star's presence briefly reshapes the light passing by. It may be that this is one of the quieter wonders hidden inside this entire phenomenon. Even something as commonly overlooked as a single ordinary star carries enough gravity to leave a small gentle fingerprint on the light travelling near it. A fingerprint patient enough to wait sometimes for years for the right alignment to finally reveal it. Neuroscientists studying perception have observed that the human mind tends to assume almost automatically that what is seen represents the world exactly as it is, position, distance, shape taken largely at face value. Gravitational lensing offers a gentle, quiet correction to that assumption. Some of what is seen in the night sky is not simply distant, it is also in a sense slightly rearranged, gently reshaped by the unseen mass of everything light has passed by on its long journey here. There is no need to feel unsettled by that. If anything, it can feel almost comforting. A reminder that the universe is not cold and indifferent in its complexity, but elegant, interconnected, every massive object quietly influencing the path of light from everything around it, weaving distant places subtly together through nothing more than the gentle curve of space itself. Astronomers sometimes describe these massive foreground galaxies, the ones responsible for bending and magnifying more distant light, as gravitational lenses, a term that captures something quietly poetic about the whole phenomenon. The universe, it seems, has been quietly building its own lenses for billions of years, vast and unintentional, made of nothing but mass and curved space, patiently gathering and focusing light that would otherwise have drifted past unseen forever. It seems gentle to consider that some of the faintest, oldest light ever captured by human instruments did not arrive simply because it travelled far enough. It arrived because somewhere along its impossibly long journey, something massive and quiet helped bend it gently back into view. Beyond even this bending of starlight and galaxies, there is a kind of light older than any star. A kind of light that does not come from any single source at all, but seems to fill the whole of space itself, faintly, evenly, like a memory the universe has been quietly holding on to since its very first moments. There is a kind of light that fills the entire universe at once, faint, steady, and far older than any star that has ever shone. It does not come from one direction. It comes from everywhere, equally quietly, the way warmth might still linger in a room long after the fire that made it has gone out. It seems that this is one of the more extraordinary discoveries in the story of light. The realization that the universe itself still carries a kind of afterglow from its very beginning, Scientists call it the cosmic microwave background, and what we understand so far suggests it is the oldest light that can ever be observed. Light that has been travelling uninterrupted for nearly the entire age of the universe. It was released not from a star, not from a galaxy, but from the universe as a whole at a moment roughly 380,000 years after its earliest beginning, when everything that existed was still hot, dense, and far too crowded for light to travel freely. There is something gentle in imagining that, a universe so young it had not yet learned to let light go. Before that moment, researchers explain the universe was filled with a hot, glowing plasma, a dense mixture of particles so tightly packed that light could not move through it in any meaningful way. It would travel only a tiny distance before being absorbed, scattered, and absorbed again, trapped in an endless glowing fog. As the universe expanded and slowly cooled, something quietly shifted. Particles that had been moving too quickly to settle into stable atoms finally slowed enough to combine, forming the simplest atoms, mostly hydrogen, drifting gently into existence for the first time. And in that exact moment, space suddenly became transparent. Light trapped for so long was finally free to travel. It may be that this is one of the gentlest images the universe has to offer. An enormous ancient release light finally allowed to leave, finally allowed to simply go. That light has been travelling ever since, stretching slowly across an expanding universe for nearly 14 billion years. As space itself has expanded, the wavelength of that ancient light has stretched along with it, shifting gradually from the intense brightness it once carried into something far gentler, far cooler, now arriving as faint microwave radiation barely perceptible, evenly spread across every direction of the sky. Studies indicate that this faint glow was first detected almost by accident in the 1960s by two researchers testing a sensitive radio antenna who kept picking up a faint, persistent hum they could not explain. They checked their equipment. They cleaned out what they believed might be interference. The faint signal remained present in every direction day and night, regardless of where the antenna was pointed. It was not noise. It was the universe itself still gently echoing its earliest moment. There is something quietly moving in that an enormous cosmic event discovered, not through a grand telescope aimed dramatically at the heavens, but through a soft, persistent hum that simply refused to go away. This faint background light is remarkably uniform, nearly the same temperature in every direction, differing by only the tiniest of fractions from one point in the sky to another. Yet, it is precisely those tiny differences scientists are still exploring, exactly how that hold enormous significance. These small variations in temperature reflect the slight unevenness present in the early universe. The faint seeds from which galaxies, stars, and eventually planets would slowly grow, drawn together over billions of years by the patient pull of gravity. It seems gentle to consider that everything seen in the night sky, every star, every galaxy, every quiet point of light can trace its origin back to these almost imperceptibly small variations present in this ancient light from the very beginning. Unlike starlight, which arrives from one particular point in the sky, this ancient background light arrives from everywhere at once. An immense glowing shell surrounding everything, marking the very edge of what can be observed. Astronomers sometimes describe it as looking back toward the edge of time itself, not a place in space exactly, but a moment, the earliest moment light was ever free to travel, preserved and still arriving evenly, gently from every direction at once. There is something tender in imagining that this faint light surrounds everything, constantly, the way a memory might quietly underlie an entire life without being consciously thought of at every moment. Neuroscientists studying perception have observed the human mind tends to think of memory as something personal, something contained within a single mind. This ancient light offers a strange and quiet counterpart to that idea, a kind of memory belonging not to any one person, but to the universe as a whole, a faint echo of its very first transparent moment still gently present, still arriving in every direction, including straight through this very room tonight. It may be that very few things capture stillness quite the way this does. A signal that has been travelling for nearly the entire history of existence, asking nothing, announcing nothing, simply continuing. This faint glow also offers a kind of reassurance, gentle and quiet, about how thoroughly understood the universe's history has become. Evidence suggests that the precise patterns within this ancient light align remarkably closely with predictions made by careful mathematical models of how the universe should have evolved. Models built entirely from theory later confirmed by this very light. It is in its own way a kind of conversation across an almost unimaginable span of time. An early universe, leaving behind a faint signature, and a much later universe filled with curious minds and careful instruments finally listening closely enough to hear it. There is something quietly moving in imagining that conversation. Not loud, not dramatic, simply patient light travelling for billions of years, waiting for something capable of understanding it to finally come along. Even now, this faint light continues arriving constantly, evenly, everywhere, a soft and steady presence surrounding the whole of existence. It does not illuminate anything in any practical sense. It cannot be seen by human eyes, but it is there quietly, continuously, in every direction, a kind of background hum to the universe itself, present in the space above this room, just as surely as it is present everywhere else. The mind quietly registers very little of this directly. Of course, there is no sensation, no visible glow, nothing the eyes could ever notice on their own. And yet knowing it is there, gently filling the space above and around everything, can offer its own kind of quiet comfort. A reminder that stillness and constancy exist on a scale far larger than any single night, any single room, any single life. It seems fitting somehow to end this particular thought here with light that asks for nothing, reveals nothing dramatic, and simply continues faithfully the way it has since the universe first allowed it to travel freely. And yet light does not only exist on this vast ancient scale, it also exists somewhere far smaller, far closer, somewhere inside living things themselves in the deep sea, in certain insects, in places where light is not received from somewhere else at all, but quietly created from within by life itself. Far beneath the surface of the ocean, past the point where sunlight can reach at all, there exists a kind of darkness so complete that human eyes, even fully adjusted, would find almost nothing to hold on to. And yet that darkness is not empty. Scattered through it quietly, unpredictably, small points of light drift and glow, made by living things themselves, with no sun, no fire, no external source at all. It seems that life in certain places learned to make its own light. Researchers have found that the vast majority of organisms living in the deep ocean, far more than most people would ever guess, are capable of producing light through their own bodies, a phenomenon called bioluminescence. It occurs through a chemical reaction most commonly involving a light-emitting molecule called luciferin and an enzyme called luciferase, which work together to release energy in the form of light rather than heat. Unlike a flame or a bulb, this kind of light is produced almost without warmth at all, a soft, cool glow created entirely through chemistry rather than combustion. There is something quietly remarkable in that. Light, usually associated with burning with heat, with something being consumed, here arrives gently, instead created without sacrifice, without waste, simply as the quiet result of two molecules meeting in the dark. This light serves many different purposes depending on the creature producing it. Some small organisms use it defensively, releasing a sudden burst of glowing light when disturbed, startling or confusing a predator long enough to slip away into the surrounding darkness. Others use it as a lure, a small glowing appendage drawing curious prey, close enough to be caught, a strategy used by the anglerfish, whose faint dangling light has become one of the more recognizable symbols of the deep sea's strange glowing patience. Still others use light to communicate faint patterns and rhythms of glowing signals passed quietly between individuals of the same species, a kind of language built entirely from brightness and timing rather than sound. It may be that this is one of the more tender discoveries hidden within the ocean's depths, that even in a place utterly without sunlight, life still found a way to speak in light gently, deliberately, across a darkness that might otherwise feel like silence. Bioluminescence is not limited to the deep sea either. Closer to the surface and even on land, fireflies offer one of the more familiar examples their soft pulsing glow created through the very same basic chemistry, luciferin and luciferase, working quietly within their small bodies on warm summer evenings. Each species of firefly tends to produce its own particular pattern of flashes, a private rhythm used largely to recognize potential mates in the darkness, a soft and steady code blinking gently across fields and gardens, mostly unnoticed by anyone not specifically watching for it. Psychologists often note that fireflies hold a particular emotional resonance for many people, often tied closely to memories of childhood, of warm evenings of quiet wonder at something glowing softly in the dark for no reason anyone needed to understand at the time. It may be that this reaction is not incidental. A small living light appearing gently in darkness, asking nothing, threatening nothing, has likely felt comforting to humans for a very long time. There is something gentle in imagining that this feeling drawn simply toward a small glow in the dark may itself be something quietly old, carried forward long before anyone understood the chemistry behind it. Certain fungi too produce their own faint glow, a phenomenon sometimes called foxfire, where decaying wood deep in a forest at night can emit a soft greenish luminescence faint enough that it is easily missed unless the surrounding darkness is nearly complete. Scientists are still exploring the exact evolutionary reason certain fungi produce light at all, though some research suggests it may help attract insects capable of spreading their spores further through the forest, a quiet exchange between glow and movement light, offered gently in return for a small unintentional favour. There is something almost peaceful in imagining a forest floor completely dark to human eyes, passing by in daylight, quietly glowing on its own at night, entirely unconcerned with whether anyone happens to be present to notice. Even within the ocean itself, the variety of bioluminescent life is extraordinary. Tiny organisms called dinoflagellates, often too small to be seen individually, can cause entire stretches of ocean water to glow faintly blue when disturbed. A wave breaking along a shoreline at night, sometimes briefly illuminated by countless thousands of these microscopic creatures, each one releasing a small burst of light in response to the movement in the water around it. Evidence suggests this glow may serve a defensive purpose as well, startling small predators, or in a strange twist drawing the attention of larger predators toward whatever disturbed the dinoflagellates in the first place. Light used here, almost like a quiet alarm passed outward into the dark water. It seems gentle to consider that an entire wave glowing faintly along a midnight shore may be the combined quiet response of countless tiny creatures, each one reacting in its own small way to the same gentle disturbance. What makes all of this particularly striking is how efficient this kind of light production tends to be. Unlike a typical light bulb, which loses a significant portion of its energy as heat, bioluminescent reactions convert nearly all of their energy directly into visible light, an efficiency that human technology has only partially managed to replicate even with modern engineering. Researchers studying these natural processes have noted that understanding bioluminescent chemistry has already contributed to several scientific tools, including methods used to detect specific molecules in a medical research, light once again offering insight in places far beyond where it was originally created. There is something quietly moving in that a glow first observed in deep dark water eventually finding its way into laboratories helping illuminate questions about health and biology entirely removed from where that light was first noticed. The mind quietly registers bioluminescence as something almost magical, even after understanding the chemistry behind it. Perhaps that feeling does not need to fade simply because an explanation exists. Knowing that luciferin and luciferase are responsible for a firefly's glow does not make a summer evening any less gentle. Understanding the defensive role of a dinoflagellate's flash does not make a glowing wave any less beautiful to witness. It may be that some things remain quietly wondrous precisely because they are understood, not in spite of it. The chemistry explains how the light is made. It does not explain away the soft, quiet feeling of seeing it. There is a strange comfort, too, in considering how much of this glowing life exists completely unseen, deep in the ocean, deep in dark forests far from any human eye, simply continuing quietly, faithfully the way it always has, regardless of whether anyone happens to witness it on any particular night. The mind, it seems, has been keeping something still and patient all along, something not unlike this quiet, self-made light, a steadiness carried within largely unnoticed, until the noise of the day finally begins to fade enough for it to be felt. There is a particular hour somewhere between waking and sleep, when the body begins something it has practiced every single night of a person's life, and yet almost no one ever feels it happening directly. It seems gentle to consider that sleep is not simply something that arrives, it is something the body slowly prepares for hours in advance, largely without permission or awareness from the conscious mind at all. Researchers have found that as evening progresses, the body begins a quiet internal sequence guided in large part by the gradual fading of light. Deep within the brain sits a small structure called the pineal gland, which responds to signals received from the eyes about surrounding brightness. As light dims, this gland begins releasing a hormone called melatonin into the bloodstream, gradually, steadily rising over the course of the evening, reaching its peak sometime in the middle of the night before slowly receding again as morning light returns. There is something quietly devoted in that rhythm, a small structure deep within the brain, faithfully tracking light it cannot see directly, producing exactly what the body needs, exactly when it tends to need it night after night, largely unnoticed. Melatonin itself does not force sleep the way some people imagine. It does not switch the body off the way flipping a light switch turns off a room. What we understand so far suggests it functions more like a quiet signal, a gentle suggestion passed throughout the body that darkness has arrived, that the time for rest is approaching. It lowers body temperature, slightly eases certain systems into a calmer state, and softly nudges the body towards sleep without ever fully controlling the moment sleep actually begins. It may be that this is part of why forcing sleep so often fails to work. The body does not respond well to demands. It responds instead to softness, to dimness, to the same gentle cues it has relied on for longer than memory can reach. This entire process is deeply tied to the circadian rhythm, the same internal daily cycle responsible for regulating alertness and rest across roughly 24 hours. Neuroscientists have observed that this rhythm does not rely on melatonin alone. Body temperature follows its own quiet pattern, as well, rising gradually through the day, peaking in the late afternoon or early evening, and then slowly beginning to fall as night approaches, continuing to drop through the early hours of sleep, before gently rising again toward morning. There is something sinister in imagining the body's temperature falling quietly through the night, almost like a small fire being gently allowed to settle, never extinguished completely, simply lowered, softened, eased towards stillness. Sleep itself, once it begins, is far from a single uniform state. Studies indicate that the body moves through several distinct stages throughout the night, cycling repeatedly between lighter sleep, deeper sleep and a particular stage known as rapid eye movement sleep, during which most vivid dreaming occurs. Each cycle lasts roughly 90 minutes, repeating several times across a typical night, with the proportion of deep sleep generally greater in the earlier cycles, and the proportion of rapid eye movement sleep gradually increasing as morning approaches. It seems gentle to consider that sleep is not simply one long unchanging darkness. It is closer to a slow repeating wave rising and falling in depth, the mind drifting through different layers of rest throughout a single night, mostly without ever being consciously aware of the transitions at all. During the deepest stages of sleep, the brain engages in processes researchers believe are closely tied to physical restoration, including the release of growth hormone and the repair of tissues throughout the body. Evidence suggests that this is also when certain waste products that accumulate in the brain throughout the day are more efficiently cleared away through a recently studied system sometimes referred to as the brain's own internal cleansing process, working quietly almost exclusively during these deeper hours of rest. There is something quietly remarkable in imagining that the brain using its quietest hours, not for thought, not for awareness, but for a kind of slow, careful housekeeping, tidying, gently in the dark while the rest of the body lies still. Rapid eye movement sleep, by contrast, brings a very different kind of activity. Brain activity during this stage closely resembles wakefulness, in many respects, even though the body remains almost entirely still, held in place by a temporary natural form of muscle inactivity that prevents most physical movement from occurring during dreams. Scientists are still exploring many of the deeper purposes of this stage, though. Current understanding suggests it plays an important role in emotional processing and the consolidation of certain types of memory, the mind quietly sorting through fragments of the day, weaving some of them gently into longer-term memory while allowing others to fade. It may be that dreams themselves, regardless of how strange or vivid they may feel, are simply the conscious echo of this deeper, quieter sorting work, glimpses caught briefly by an awareness that is for those few minutes only partially present. Psychologists often note that the regularity of sleep, going to rest and waking at fairly consistent times, tends to support this entire rhythm more effectively than the total number of hours slept alone. The body, it seems, values consistency almost as much as rest itself, gradually learning to anticipate sleep at certain times, easing into it more readily when those patterns remain steady night after night. There is something gentle in imagining the body as something that learns quietly, patiently adjusting itself again and again to whatever rhythm it is offered, asking only for a little consistency in return. Even breathing changes during sleep, slowing, gradually becoming more regular as deeper stages are reached. Heart rate too tends to lower gently throughout the night, the entire body settling into a slower, calmer pace, almost as though everything inside were quietly agreeing together to rest at the same unhurried speed. The mind quietly registers very little of this directly. There is no conscious awareness of melatonin rising, of temperature falling, of cycles shifting from light to deep to rapid eye movement and back again. And yet all of it continues faithfully every single night, an enormous intricate rhythm operating entirely without supervision, entirely without effort, simply because the body has practiced it for an entire lifetime and for the whole of human history before that. There is something deeply reassuring in that thought sitting quietly here now. Nothing about falling asleep needs to be managed or controlled or carefully arranged. The body already knows precisely what to do. It has been doing it every single night long before anyone ever thought to study it, and it will continue gently faithfully tonight as well, asking only for darkness, stillness, and little patience to begin its quiet work. And somewhere just beyond this nightly rhythm of rest there is something quieter still, the way all of this light and body and time gently connects every living thing under the same patient repeating sky. There is a particular kind of light that connects almost every living thing on Earth quietly, constantly, in a way most people rarely pause to consider. Not the light of stars, not the light made by living bodies in the dark, but the most ordinary light of all sunlight arriving each day, asking nothing, simply offering itself to whatever happens to be present to receive it. It seems gentle to consider that nearly all of life on this planet exists in some form because of this single continuous gift of light. Researchers have found that the vast majority of energy moving through living systems on Earth begins with a process called photosynthesis, occurring within plants, algae, and certain bacteria, where sunlight is captured and used to convert simple ingredients, water and carbon dioxide, into sugars. The organism can use for energy-releasing oxygen as a quiet byproduct along the way. This single process, repeated endlessly across forests, oceans, fields, and quiet garden corners, forms the foundation almost everything else depends on, directly or indirectly. There is something deeply moving in that a small green leaf sitting quietly in sunlight, performing one of the most essential transformations in the entire story of life, without ever announcing what it is doing. The oxygen carried in every breath taken tonight in this room, in this moment, ultimately traces back to this same quiet process. Sunlight captured by something green, transformed gently into the air itself. Scientists suggest that the very atmosphere surrounding the Earth has been shaped over billions of years by the patient continuous work of countless small organisms doing nothing more dramatic than sitting in light and converting it into something living things could use. It may be that this is one of the more humbling truths held quietly within ordinary daylight. Every breath is in a very real sense a small echo of sunlight transformed long before it ever reached human lungs. This connection extends much further than plants alone. Nearly every food eaten by any animal anywhere can be traced back link by link to something that once captured sunlight directly. A deer eats grass that grew using light. A wolf eats the deer. Even creatures living far from any visible sunlight in caves in deep soil in the depths of the ocean often depend in less direct ways on energy that originated at some point somewhere from light reaching a living surface. There is something quietly profound in imagining this, an enormous invisible web stretching across forests and oceans and quiet backyard gardens, every strand of it touched eventually by the same simple gift sunlight, arriving patiently day after day asking for nothing in return. This relationship between light and life is not limited to providing energy either. Evidence suggests that light itself, its presence, its absence, its particular qualities throughout the day, helps regulate the behavior of countless species far beyond the circadian rhythms already gently explored earlier this evening. Flowers open and close according to light. Certain fish migrate based on subtle shifts in daylight length across the seasons. Entire ecosystems quietly reorganize themselves as days grow longer or shorter. A slow, patient response to nothing more than the changing angle of sunlight reaching the Earth. It seems gentle to consider that an entire forest, an entire coral reef, an entire field of wildflowers is in its own way constantly listening to light, adjusting itself accordingly, season after season, without ever needing eyes to do so. Even the length of daylight itself carries enormous influence. Many plants determine when to flower based on the relative length of day and night, a sensitivity scientists call photoperiodism. Some species flower only when days grow shorter, others only when days grow longer. An internal calendar built entirely from light, far more precise in many cases than anything a human calendar could offer. Neuroscientists studying plant biology, a field sometimes touching closely on neuroscience, despite plants having no brain at all, have observed specialized proteins capable of detecting incredibly subtle shifts in light, fractions of a percent in day length fine enough to coordinate blooming across enormous distances, all in quiet response to the same gentle shared sky. There is something tender in imagining that fields of flowers across an entire continent quietly coordinating themselves to the very same shifting light, blooming together gently season after season, with no communication between them other than the sky itself. This deep relationship between light and living things may also help explain why so many people feel an instinctive pull toward light, particularly during darker months. Psychologists often note that reduced daylight, especially during winter, can meaningfully affect mood and energy in many people, sometimes described as seasonal affective patterns. A quiet reminder that human beings, for all their complexity, remain deeply tied to the same rhythms of light that shape nearly every other living thing on Earth. It may be that this is one of the gentlest truths to rest with tonight. Humans are not separate from this vast light-driven web of life. They are simply one more thread within it, responding quietly, instinctively, to the same patient light that shapes forests, oceans, and quiet fields of flowers. There is also something quietly beautiful in considering how light connects living things across enormous spans of time, not just space. The energy stored long ago in ancient plants, captured originally through sunlight hundreds of millions of years in the past, remains present today in coal, in oil, in natural gas. Sunlight from a deep and distant past, still quietly providing warmth and energy in the present long after the light that originally created it has gone. What we understand so far suggests this is among the more poetic realities within Earth's science, that some warmth felt today, some light still glowing in a lamp, this very evening may trace its origin back through an unbroken chain, all the way to sunlight that touched the Earth, long before anything resembling a human eye ever existed to witness it. There is no need to hold on to every detail of that. It is simply enough to let it settle quietly the way warmth settles into a room after a long day present, comforting without needing to be fully understood to be felt. Underneath all of this, the photosynthesis, the migrations, the careful blooming of flowers, the energy stored across millions of years, there remains one simple quiet thread. Light arrives, life responds, quietly, patiently, the way it always has, long before anyone thought to study why. And as this long, gentle exploration of light slowly begins to settle, there remains only one part left, the softest part of all, where the day finally lets go entirely, and rest is allowed to arrive undisturbed. There is one more kind of light worth resting with tonight, the gentlest one of all the kind already settling somewhere in this very room, dimming slowly the way it does at the end of every day. It seems fitting to return here at the end to where this all began. Light arriving quietly from somewhere else, carrying with it some small trace of distance, of time, of an old and patient journey. Researchers have found that the eyes even now are still doing their quiet work, gathering whatever light remains, however faint, and gently passing it inward, the way they have throughout this entire evening, the way they have for an entire lifetime, without ever once stopping to rest themselves. There is something tender in that thought. The eyes give so much of their attention to the world and ask in return only for darkness eventually and a little stillness. Somewhere above this room, starlight continues arriving the way it always has, light that began its journey long before tonight, long before any of these words were spoken, still quietly completing its long and patient path. It may be that some of that light is only now in this very moment reaching the place where it was always meant to arrive. Nothing about this room needs to change for that to be true. The lamp dimming, the window dark and calm, the faint hum of something electrical somewhere distant fading slowly into the edges of attention. The body by now has likely already begun its own quiet preparations. Temperature easing downward, breath slowing, somewhere deep inside a small and steady rhythm continuing patiently the way it has every night before this one. There is no need to notice all of it. There is no need to notice any of it really. Light has been arriving all evening, gently, without asking for anything back. The same will continue now quietly in the background the way it always has. The eyes may close soon if they have not already, and even then light continues. Somewhere very faintly the last of it is still moving through the dark, soft, patient, still arriving, still here, drifting gently into rest.